Hey base builders, are you ready to change how you develop forever? The Coinbase Wallet API v2 is here in alpha with one secret to rule all chains. Why this matters? Building secure on-chain apps have always been a painful key management until now. V2 changes everything because your private keys are stored securely in hardware vaults, otherwise known as TEE, Trusted Execution Environments. And then you have one secret which unlocks every single network across EVM chains like Base, Optimism, and Ethereum, as well as on Solana. You'll never need to manage your keys again. And what you'll be learning today is that I will be building a complete cross-chain app in less than 5 minutes. You'll be able to send transactions on any network that you want, deploy it on Vercel, and it'll all be completely secure, backed by Coinbase Developer Platform's SDK. Let's reinvent crypto development together. This is going to be a full masterclass, so let's get started with some information before we dive into the actual code itself. I'll get started by sharing my screen, and then I'm going to put the QR code for you to get these docs in the top left corner. So if you're watching this and you would like to join in and follow along, you can either scan the QR code that's in the top left, or if you see that URL, we're at docs-wallet-v2.vercel.app. And so to quickly cover what Wallet v2 is and its differences, this is a brand new Wallet API from the Coinbase team. And they made a lot of changes based off of the shortcomings of the original v1. In v1, the security management was very complex, and in v2, it's easy. Private key security was something that I was constantly hitting. In v1, we had to manage this text file or store it as an environment variable. But now all of our private keys are stored in an AWS Nitro enclave with TEE. That means that I don't have access to the private key. That means that the Coinbase team doesn't have access to the private key. This is the future of private key storage and giving an AI agent a trusted computational space where no human can mess with it, giving the AI agent more autonomy. In this case, we're giving AIs autonomy over the private key management, knowing that no other human is going to go in and get that private key and use it for their own means. Everybody knows that the private key is stored in one very secure location. Network support before, we only had EVM network supports, and now they're bringing out Solana. I'm not going to be talking about Solana in this video. I am a firm believer that EVM is the best computational platform. And so for me, I'm going to be sticking with EVM in this video. But just know if you are a Solana builder, this video will also apply to you. And you can follow the original docs, which I have linked on the Getting Started page. You can follow the official Coinbase docs if you want to learn more about the Solana integration. Authentication is a key point that I also am loving the new direction. Before, you had one secret per account, and now you have one single secret for all accounts. And so before, it was I would create a wallet and I had one wallet address, and that was all I had. If I wanted more, I had to manage an additional text file for each wallet that I wanted to manage. Now I can just use one single secret that I'll show you how to get that secret in a little bit. And if you use that secret, you can then spin up as many accounts as you want. So for me, I'm building products like Recoup, Coop Records, In Process, Excellencia's Map, Tenno is on his world tour. And for each of those projects, I want to be giving and using accounts behind the scenes. And so now with Wallet v2 API, what I can do on platforms like Recoup is every single time someone logs in with Privy and then they need to sign a transaction, I can spin up a new wallet, use that brand new wallet to sign the transaction, and then store whatever asset we're creating inside of that Privy wallet. And so each transaction, I can spin up a brand new account, use a paymaster for that so that it doesn't need to have any sort of funds, use it to sign a transaction, and then whatever the asset is, send back to the wallet. That's going to make it so that the wallets that are connecting to my site don't need to physically sign as many transactions, which means safer experience for that wallet. You don't need to sign, which means you're not going to expose any of your assets, which means a safer experience. Well, at the same time, if you're creating tokens on In Process, or if you're creating assets using the Recoup AI agent, and you want those AI assets to have the provenance back to your original wallet, we can still do that. So we can be using the Coinbase v2 Wallet API to spin up and sign transactions with a one-time use for one single transaction. Ditch those because we're using a paymaster. It doesn't actually have any ETH sitting inside of its wallet. And then store those assets that we're creating inside of the actual wallet, whether it's an external EOA, if it's a Privy wallet, if it's another Coinbase Smart wallet, reducing the transactions from you and your special wallet where you store all your funds and all your assets while still giving you an easy experience of not needing to fund an app wallet, not needing to worry about ETH and signing transactions and the insecurities. The wallet scope and the authentication of a single account for a single secret for multiple accounts, as well as a single wallet that works across every single network, are two major benefits that we're getting in the new V2 wallet API that we did not get in V1. If you're an app builder and you've been struggling before to use the Coinbase wallet API, I highly encourage you to be checking out and following along in this video to see all the benefits of how the V2 API works. And I'm going to be showing you from start. We're going to be following the Coinbase. We're going to be following the Coinbase documentation, and then I'm going to expand the Coinbase documentation to show you how we can deploy it for free on Vercel. The last couple things, it is VM compatible, which is excellent for this tutorial because I use VM as a library for wallet management and everything that I do. I think it's the industry standard, and the fact that Coinbase Wallet V2 supports this right out of the box is a game changer. Gas sponsorship, what I was just talking about with Paymasters, we can use Paymasters now because we're using smart wallets from EIP 4337. And then spend permissions is another thing where we can have a central account and then we can have smart wallets off of that. And those smart app wallets can have permissions to spend from the core wallet. We're not going to be using spend permissions in this video, but we will be showing gas sponsorships. We'll be covering VM compatibility. We'll be showing the new private key management. So that'll allow you to see the security management and the authentication. We're going to be showing most of the details in this. And so now that I've got some time to explain what the big feature shifts are from V1 to V2, let's start going into the actual quick start. This is following the official Coinbase docs. I took the official docs that they had and I reorganized it a little bit. The main change that I made is Coinbase starts you off with an environment setup. And I thought for me personally, that was a little bit confusing without having an initial project. And so we're going to start, in my example, we're going to start down here in initializing the project, installing the package, setting up our main file, and we'll get down to here to about to execute it. And after that, we will then set up our environment variables. And after our environment variables are set up, we're going to go through each of these little examples of create an EVM wallet, fund the wallet using a faucet, creating a smart account, and then executing transactions. All of those I've got outlined here: creating an EVM wallet, fund a wallet, create the smart account, and send a general transaction. And so we're just going to follow along with a slightly different example that I created just to make it easier for me to give this masterclass that I'm giving right now. Again, all this docs that I'm following and that I'm explaining are open source. You can find the docs by scanning that QR code in the top left. I'm sorry, the top left up there. And yeah, without further ado, let's start diving into the code. In the Wallet V2, it allows you to create on-chain accounts to send funds within minutes. And so in this quick start, you're going to learn how to create an EVM wallet, fund it with testnet, and transfer funds between your accounts. By the end of this section, what you're going to learn is how to install the Coinbase V2 CDP SDK, how to create an EVM wallet, how to fund your account with testnet, how to create an EVM smart account, and then how to use EIP 4337 user operations, Paymaster, and other smart account only features like batch transactions. Requirements. For using the CDP SDK, you have to have at least Node.js version 18 or higher. And so to use that, you can click this little copy button. We will open up, I want this open up over here. If I move my terminal over here, there it is. That's what I'm looking for. Okay. So I just want to open up my terminal, and from here, let's run that command of node version. I'm on Node.js version 23. Let me try to make this bigger. Oh yeah, and it's also blocked by the QR code. Can I move that QR code into the bottom? Is that possible? Or move it onto the right side? Cool. So now we've unblocked my terminal. Now we've unblocked my terminal, and you can see that I am on Node.js. Goodness. There we go. Now you can see my terminal's on version 23 for my Node.js version. let's keep moving through. So the next thing I'm going to do is I'm going to create an example. I'll copy. I don't know why it keeps opening it up over here. I mean, if that's where it naturally wants to open, I'm going to quickly change my screen sharing to a different screen. And now I'll move around some of my tools to make it so that it's all going to work over here. There we go. Okay, so now let's paste that command. CDP wallet v2 example, we'll change directory inside of it, and then we'll set up a brand new node package. I'm inside of my project. If we expand this, we should see everything that it just did. We created a brand new node project, and really all that means is that we've given it a package.json. I'm going to open up this project so that we can start to play around inside of it. And so now we've got our project, which really is just a package.json file, and we can keep going with these instructions. The biggest thing we need to change is we need to change it to type module. And so I'll open up the package file, and then right after the scripts line, I'll make it of type module. Now let's install the CDP SDK by copying and pasting the install command, npm install at Coinbase CDP SDK. And with this, it's going to install the latest version of the Coinbase Developer Platform SDK, including the Wallet v2 API. All right, we've installed the SDK, and now let's create a main file where we will be running the app. Let's see if we've got it there. So now we've got a package lock, we've got our node modules, and we've got a main file. Inside of our package, we now have one dependency of the Coinbase SDK, and that is everything. So at this point, now we can pick our flavor of what we want to fill in. We'll start with the creating of an EVM account, but before we get there, let's go through our environment setup. For environment variables, I'm going to make a new file in here called .env, and I'm going to use this to manage the keys for this specific session. In order to get our keys, I've got instructions laid out on how you can get all the keys that you're going to need, including a CDP API key and secret, a wallet secret, and then we also need a Paymaster API key, which I actually forgot to include in here. But I'll walk you through it all here on the video. So if you don't know how to get the Paymaster, it should be relatively simple, but I'll show it all right here. We'll go to our list of projects, and I'm going to briefly delete the old project that I have in here that I'm no longer using, and then we'll create that project again. I'm going to call it delete wallet v2. And so now I'm going to create a new project. I'll call this delete wallet v2, and I call any project delete if I'm sharing the public keys or the private keys. That way I remember to come back in and delete it afterwards, but it also allows me to share all the details with you on the stream for research purposes. So go into the API keys tab, and then you'll see a create API key button. I'm going to just name this key, and now you can create and download. This is going to give you the API key ID and the API key secret. If you copy the ID, what I'm going to do is copy these values and paste them inside of my env file. And now I'm going to paste these values in here. This is why I wanted to have a project first, so that I had a place to paste my keys. So we get the key ID, we copy the key secret, we paste the key secret, and now we just need the wallet secret. And we can just navigate. There's two different ways we could get there. We could either close out of this pop-up, go to wallets, and then click wallet API. Or additionally, if you're here inside of my docs, I've got a generate wallet secret. You click on that link and it opens up the same page. They're both taking you to portal.cdp.coinbase.com/products/wallet API. And so what we do in here is we click generate. That'll download our key. And now we have a wallet secret that we can use to generate new wallets. The last thing I'm going to get is a CDP Paymaster URL. And this is going to allow me to cover all the gas costs of any transaction we sign. Inside of on-chain tools, you go to Paymaster, we go to configuration, and I'm going to swap this to base testnet for Sepolia, copy that URL, paste it inside of here, and now we've got all the environment variables we need. And from here, we can follow the command that the Coinbase team wants us to follow, which is to export them. And so to export them, I'm going to lay it out right here. And we'll copy the variables that they want us to export. I'm just using this to make it easier for me to copy and paste the variables that they want us to export. Okay, I've copied all of them. And from here, I'll just copy all three of those lines, open up my terminal, paste it in there. And now we can verify we have any of these by running echo $, for example, CDP API key ID. CDP API key ID gives us back our value, and we could do that for any of them. So we have successfully loaded in the variables that they need. For now, I'm going to close out of my environment variables file. I'm also going to close out of, we'll keep it open, who cares? And let's keep moving on with our setup. So we've now exported the variables. Some security recommendations while I'm here sharing all my environment variables for everybody's awareness. When working with API keys and secrets, make sure to never commit your secrets to version control like Git. Also consider using a .env file with a package like .env, or if you're using Next.js, it'll automatically read a .env.local. Whitelist IPs in production environments if you're using these API keys in a deployed environment to only allow specific IP addresses to use the keys that you deployed. And every once in a while, rotate your API keys, just like I'm going to do after this. I'm going to go in and I'm going to delete this project, or I'm going to rotate my keys. That way, even if you were able to get access to my keys, I'm constantly changing them to practice best practices in my security. Now that we have our environment variables, we have our project, let's go through with the Coinbase examples to get a good understanding of how this works. Here is all we need to do to create an account. It's literally 4 lines of code, and one of those lines of code is a console log. Let's copy this code, go into our main file, paste that code, save the code. And now all that we need to do, as was noted inside of the quick start, is we just need to run npx tsx main. And that's going to be the command we'll keep coming back to. So I'll open up my terminal, I'll run that command, and let's see if it works. And we just got an account. So we have just, in about 20 minutes, we've gone through all of our examples, we've set up a brand new project, and now we are creating accounts on the brand new Coinbase Wallet v2 API. I can run this again, and it'll give me a brand new account. And you can see before we got account with 9B7B ending with 8517. This time we got a new account with 382 ending with 7238. And so this is highlighting the first difference already that we were talking about at the beginning. Before we had authentication, we had 1 secret per account, and now we have a single secret for all accounts. And before we were only able to do 1 single account, and now we have multiple. And so as you just saw, we didn't have to change our private keys, and we went from 1 account to a new account, and we can keep calling this and keep spinning up new accounts. And I didn't have to put in any sort of credit card information. I'm just spinning up accounts using the Coinbase SDK. And unlike previous, if you just use VM, you'll be creating private keys, and then you'll need to store that private key somewhere. And if someone gets access to that private key, they can steal all the funds. But now with Coinbase, we're using a trusted execution environment. And so I don't have access to that private key. Coinbase doesn't have access to that private key. It's secured in an AWS Nitro enclave in a trusted execution environment, which is safer private key management. And so even though I'm spinning up all these keys and I might not be keeping track of them, that's fine. I can be a small brain dev and I can just keep creating accounts, and it doesn't matter. I can create as many accounts as I want. And so this is highlighting one of the first benefits that we get with the new Wallet v2 API from Coinbase that we didn't get back with the Wallet v1 API. All right, so we've created a v1 EVM account, that's fine, but how do we fund it? Right now we've got a wallet, but it doesn't have any funds in it. Let's see how we can fund that wallet by copying our second example of funding an EVM wallet. In order to change our code, we'll just totally overwrite what's inside of our main document, open up our terminal, and run the same command of npx tsx main.ts. This time we're going to do the same thing of creating a wallet. And actually, I would like to see what that wallet is. So let's console.log created an account. Let's run it again, because again, we can run this as many times as we want without any repercussions. And so we spun up a brand new account and then we funded that wallet. Let's open that up to see the transaction. I'm gonna move this over onto the screen so that y'all can see it. Oh, I've already got a, whoops. Let's take this, close out of this, open up a new tab. And now we're looking at that funding transaction on chain. 24 seconds ago, we were able to transfer ETH from a random wallet into this wallet that is A6E. A6EC is the wallet that I just created. And so if we check out this wallet, we should have just created a new wallet and it's funded. So we can check out that address. And when we look at it on chain, we can see it does have a balance. It was funded at this transaction, which was 1 minute ago. So now every time we create a wallet, we're funding that wallet, and we can do that unlimited times. Let's do it again over here. If we run it again, we'll get our wallet address. And now that we have our wallet address, we then got the wallet funded. So let's run through that. We can run this as many times as we want. Let's open up that new tab. We can see we just had a transfer 5 seconds ago, and that transfer should have been going to my wallet, which ends in D99A, which it does. I'll check out that wallet that I copied over to my clipboard. This is a brand new wallet. It's got funding of 0.0001 ETH, and we can see that that funding happened 24 seconds ago in the same transaction. Just to really show the point of how easy it is, I don't like either of those two wallets I just spun up. I want another one. Run this one command. It's going to create a brand new wallet for us. It's going to then fund that wallet, and it does it all in the time that I'm sitting here yapping. We'll copy this wallet address, and let's go straight to that wallet address. There's a brand new wallet. Go to the address, and we can see it was funded with 0.0001 ETH at a transaction that was executed 11 seconds ago. We have now, let's check in with where we're at in our example. So far, we've already shown you how to create an EVM wallet, which you just call cdp.evm.createAccount. And then if we want to request funds from a faucet, we use cdp.evm.request_faucet. This is all great. We're using one level of account. These accounts are awesome. But what if we want to use a smart account? Smart accounts are great for using any operation that we have in EIP 4337, which includes paymasters, batching transactions, smart account spend, and other awesome benefits that we're getting in the world that we're moving to of smart accounts. Smart accounts need an account that owns it. And so that's why the Coinbase SDK allows you to create that initial account. And from that one account, you can spin up unlimited smart wallets. And so what we will most likely move to on our team is we'll spin up one account. We'll potentially save that account into storage, either as an environment variable or in our database, just to have that reference. And then from that single account, we'll spin up unlimited smart accounts all the time to be able to use those smart accounts for signing transactions on behalf of the people who are signing our app. The goal for me is to build on-chain apps where people don't need to have the interruption of a signing of a transaction. They don't need to know what ETH is. They don't need to know what gas is. They don't even need to know that this stuff's happening on-chain. For me, on-chain infrastructure is better. It provides transparency. It provides instant access and instant ability to send funds. It allows anybody in the world to have a digital wallet and no need to KYC. It's my favorite way to be building applications. I don't have to worry about if I stop paying that my app is going to go away and all the people who have trusted me that their data is going to go away. Your data is permanent when you store it on Ethereum and on EVM chains. And that's something I like keeping instead of just storing everything inside of Supabase. And then if I stop paying, my Supabase instance widens down. And if people want to say, hey, can I peek under the covers at what's going on in the Supabase database? I'm sorry, I'm going to have to build API endpoints for you. But if I had just stored that info on chain, I'll just give you the transaction hash. I'll give you the contract address, and you can go and look at those. By building on chain, it provides a much more accessible infrastructure for me to build on top of, as well as for me to be able to share with others, for others to be able to build on top in a composable way. And so building with the Wallet v2 API is going to give me as a builder an access to do things on chain without having to add on the friction of having people connect to wallet, them needing to sign transactions, them needing to have ETH in their wallet or know what gas is, or whoops, your gas is on the wrong chain than the chain that we're using. I'm going to be putting it on chain for you behind the scenes as the builder. If later on you want access to that, great. I've already sent all those assets into your wallet that you connected with Privy at the start, but you didn't need to worry about the friction of signing. If you're on your mobile device, we all know how hard it is to jump people from your app into their mobile app. Doing away with all of that using Coinbase Wallet V2 to just sign transactions using a smart account under the scene. Now that I've done that little bit of yap, in order if we want to create a smart account, we'll do the same thing of create an EVM account. And then we will use that, we'll create a smart account with cdp.evm.create smart account. And all that you need is an owner of that smart account. And in this case, we will give that smart account to the new wallet that we have just created. Let's see if this works. We'll copy this code, go back to our main, and from here, we're creating a smart account. I also would like to see console.log EVM account. Let's do it before console.log EVM account. I actually want this to say created an EVM account. And now we can go EVM account dot address. Let's run this. And this time we should see, can I just get rid of all this? Yep. Running our main file, we should now get two wallets, the main account and then a smart wallet. So now we're spinning up two accounts instead of one. We're first creating a normal account, and then we create a smart account, which follows EIP 4337. And we can do this again as many times as we want. I can just keep creating accounts all day, every day, and we can do this unlimited times. Nobody's going to care. And this allows me to not overly invest in any one account, but use the account temporarily to do one single thing. Get rid of it. Let's do a new one, because we can spin up millions of these accounts, and it's not going to make a dent in the overall addressing space of EVM addresses. So that's how you create a smart account. Just use cdp.evm.create smart account, pass in the owner address, and that's how easy it is to start creating smart accounts with the new Wallet V2 API. All right, so we have been able to create an account, we've funded an account, we've created smart accounts. Now let's go into general transactions. Smart accounts support EIP 4337 standard, which allows advanced features like gas sponsorship and batch transaction. Here's an example of sending a user operation from a smart account. Inside of here, I'll copy this and then we'll put it into our docs, and then let's walk through what it is doing. Before I do, let's just see if it works. Let's open it up, open up our terminal. Let's try running it. And let's see if I wrote code that is actually going to work or not. It looks like it worked. Did I say I didn't save this, so it didn't actually use our latest changes. Let's try it again now that I've saved those changes. All right, it looks like we have just gotten an operation hash, and now we're waiting for that confirmation to resolve on chain. And now we've done a transaction on chain. Let's look at the transaction and work backwards from there. So let's go on to Basefolia scan and let's look up this transaction hash to see what happened. 14 seconds ago, we created two different contracts. Well, first we interacted with a contract, and then we created a new contract. This new contract should be my smart account wallet. And so we can see here's our smart account of 2EA6. And so that wallet contract was created, and it was created in order to sign one single transaction. And if we go into the logs, we can see an owner was added. This owner should match our original owner, which we're missing a log for. Let's run this one more time now that I can see my owner. And that way we can connect all the dots of what just happened behind the scenes. This is our first transaction using the Wallet V2 API from Coinbase SDK. We got a new EVM account that starts with D25. That EVM account is the owner of a smart account that starts with 1724. It then executed a user op. A user op is a group of transactions. It can be a batch transaction with like create a token, list a token for sale, buy that token, withdraw my earnings from the protocol. You could do all that in one single transaction. And then all of those user operations, you then wait for all of those user operations to complete, and that will give you one single transaction hash, which you can look up on chain to dive into the details of what happened. And so here we can see we should have a smart account being created at 1724. If we go into our logs, we have an add owner on 1724. The address is my smart account and it ends with 086D, 086D. So we added an owner to that smart account and that owner should be my D25 address. Here's my D25 address. If we change this from decimal to hex, well, it's not going to show it to us right, but this is our owner address. It starts with D2511, and it ends with 9076. And so we have now set that our smart wallet has an owner, and that owner is our main account. The account was deployed from an account deployer, a factory, and the account that was, it has a paymaster, it has a factory, the sender, and then user op hash, sender, factory, paymaster. I'm surprised it doesn't tell me. Oh, it does. So the sender is my smart wallet in this case. This was deploying the account. We can see the sender, account deployed. It is firing again with the same info. This looks like a duplicate of the same thing, so we won't dive into it. Before execution, so there's some hooks that fire before execution. User operation was sponsored, and there's a sponsor ID. And then we've got user operation event. This is telling us that we're using user operation event. We used a paymaster, actual gas costs, and the actual gas used, user operation event, and that's everything. So we spun up a new wallet, we spun up a new smart wallet, and then we executed a transaction. What was that transaction? That transaction was making a call to send ETH, send 0 ETH with no data. So it's really not doing anything. It's not sending anything, but this is just an example of how to use a general purpose account. And so to just walk through what this file does, just like all of our other examples, the first step, let's create an account using cdp.evm.createAccount. We log that account that was created. Now with that account, we can make it the owner of the smart account that we created. And so we created a smart account. And then we used the cdp.evm.send user operation. Send user operation is going to allow us to pass in any arbitrary function call, whether it's signing a transaction on a contract, or in this case, just sending ETH. We can do any transaction we want. And unlike a normal wallet where you only get one transaction, you'll notice that calls is an array. That means that we can actually stack multiple calls in here and they will all work. And so if we wanted to send ETH to 3 different addresses, I can send this to all the addresses that I want. Let me just, for testing's sake, let's send it to just some addresses that I see here, some random addresses. We'll send it to this address. And also whatever this random factory address is, let's send some ETH here. And again, we're sending 0 ETH, so it's not actually gonna do anything, but just to verify, before, if you're using like MetaMask or Rainbow or Coinbase wallet, you can only sign 1 transaction at a time. And so if you wanna do something like, I want to swap ETH for USDC on Uniswap, then I want to approve my USDC so that I can buy a pizza online because it's about to be Bitcoin Pizza Day. Actually, I think it might have just been last week, Bitcoin Pizza Day. And then after that, I want to swap whatever USDC is left over back into ETH because I think ETH is about to go up in value. Before, you would need to sign 3 transactions, 1 to do the initial swap, second one to make the purchase or to approve your USDC, third to actually spend that USDC, and then fourth to swap back any USDC that you want to swap back to ETH. Now with EIP 4337 and smart accounts inside of the Coinbase Wallet SDK v2 with Wallets v2, we can just batch all those transactions together using a smart account, and we can just fire those all together. And so in this example, I'm going to be sending ETH to the main owner of the wallet, a random factory address, and then another factory address, I believe. Mostly I'm just demonstrating that we can stack multiple transactions together and have all those transactions fire in one single transaction. So we created an EVM account, created our smart wallet, where we've done our user operation. We have the hash for our user operations, and now we're waiting for that transaction to be included. And now we have a hash which should include all of those transactions inside of it. Whoops. Let's go to this transaction and see what it has. Here's our transaction. It happened 11 seconds ago. And again, we're not actually sending any real ETH, so this is not a super effective test. But we're going to be going into some deeper tasks where we're actually going to be seeing the power of user ops. So I'm not going to spend too much time showing this initial step. But as you can see, we did get a successful transaction of sending ETH to multiple different accounts. You should be able to go into logs or state and see that state isn't changing because we didn't actually send ETH anywhere, or they were all empty. But so far, what we've done in this example is we have set up a standalone project. We have set up our environment variables, getting our keys from the CDP platform. We've also gotten a new wallet key. We only need one wallet key to spin up unlimited wallets on unlimited different chains. And now what I want to do is, this is the limits of what Coinbase gives us in their docs. And so if you go through Coinbase docs, they'll stop right where we stopped. Well, they have a Solana example, but we didn't go into that. You can see transferring of funds, does some fund transferring. We even went over here to accounts, and then we did the user op. So we just finished this example inside of the accounts tab of the Coinbase developer example. And so this is the limit of where they get inside of the Coinbase docs. What I think is missing from here is the ability to deploy. They don't tell us, hey, here's how you can easily one-click deploy this on Vercel. And so now what we're going to do is I wrote out my own docs for a Next.js project. And so these docs that we're going to go into now are going to show, okay, how can we take that Coinbase prototype, a very simple app, just includes an env file, a main file, package lock, and a package. Very lightweight app, but I don't know how to deploy an app like this for free on Vercel. Now I'm going to show you a new way that we could start from zero, build the same app that we just built, and then deploy it for free using Vercel. So give me just 1 second. I want to drink a quick drink of tea. And if you yourself are not staying hydrated, make sure you grab some water, take a couple sips, because if you want to be learning, you got to have a healthy brain, and a healthy brain needs liquids. Our bodies are, 80% water? And so for me, I like yerba mate. If you like water, drink your water. Whatever you can do to be hydrating and energizing your body and mind so you can have the energy you need to be learning these new concepts that are brand new and allowing us to be building awesome projects on Base. There's really 2 steps for this, I guess 3. We're going to create a Next.js application. We're then going to set up shad CN, and then we're going to install a V0 prototype that I built, which is going to include everything that we need to run this app. Then we'll set up our environment variables. After that, we'll run the application locally. And once we've run it locally, we will deploy it with the Vercel CLI. Let's get started. First step is creating a next app. So I will get out of this project, and now we'll run create next app. I'm going to call this April 28th wallet v2 app. And we're just going to select the defaults here. Yes to TypeScript, yes to ESLint, yes to Tailwind, no to source directory, yes to app router, yes for TurboPack, no for customizing aliases. And that's going to create the Next.js project for us. I like Next.js because it seems to be the industry standard. Out of all the development frameworks you could use, from Python to JavaScript to Java to Go, most developers use JavaScript. And so by me building on JavaScript, we're appealing to the widest developer base of builders. Why Next.js? Next.js is the framework built by the Vercel team, and it seems to be what most development teams use, from Rainbow to Privy to us at Recoup and KoopRex. Most teams that are building on-chain, and specifically at the on-chain music intersection, are using Next.js. It's easy to host. It runs great. It's incredibly fast. The team behind it is the same team that's building the hosting environment. And so you have great coupling between the ability to build your Next.js project and then the ability to deploy it. And so from here, it tells us the info we need to follow. Usually it tells us what we got to follow. Success, it's been created. Okay, it didn't tell us we had to change directory inside, so we'll change directory. Is that really what I named it? No, it's April 28th wallet v2 app. I don't know why I changed directory into there, so let's go back. And let's change directory into April 28th wallet v2 app. And from here, let's follow the next step of calling npx shad latest init. This is going to set up our project to use shad cn. If you don't know what shad is, it is a great library. It feels to me like an industry standard open source part of the stack that everybody uses. And so what this allows is for a common set of UI components that are lightweight, decoupled from needing an additional package, and entirely customizable. And so if you need a button, you can just install this button by running this command, and then it's going to install that inside of your repo where you can modify this button component. And this is just a template button that you can then use and customize with your own UI style. It's a great replacement to heavier things like Material UI or other UI libraries, which are pretty big and heavy. And they don't allow you to pick and choose the individual components, let alone kind of customize them, because usually they have them nested inside of your node modules. Whereas what you get with shad cn is those components are stored directly in your top level components. And so if you want to change it, you can change the core UI component, and that's fine. That's actually encouraged in the shad cn environment. So far, I haven't needed to write any code for this app. We have followed step 1 of creating a Next.js app. Then we followed step 2 of setting up shad cn. And now we're going to copy in the code that I have for the root app that we want to be building. This includes everything from the API route to the libraries. It includes CDP SDK. And I coded this with v0 doing some vibe coding. And so now I can just paste this third command. This is going to use, again, shad cn to add my v0 project into this code base. You run this, and now it's going to download all the code that I've already written using v0 so that you have an easy app that is easy to run. I think I might need to update the registry. So let me check out if I'm using the correct command by going back to v0. And let me go to my recent projects. Right here, my Coinbase wallet prototype. And now from here, I want to click the download button. And this command should give me the app that I built. It seems that I might have used an old command. While we're waiting for this, I'm going to see if there's a difference. So my original command was bbzem1uv. Okay, it looks approximately the same, but they are different. We're going to use force. It's going to install the dependencies. And so let me make a note. I do need to update my docs to include the correct v0 prototype. v0 prototype install. In the docs. I'll make that quick update. So if you're following along and you get stuck on this step, by the time you watch this video, the docs that you've been following will be fixed. It's asking if we want to override the page file. Yes, we do. This is the main change that we're doing. You can see that what we've added is an API file to create a wallet. We added the standard shad cn button, the standard shad cn alert, and we updated our page file. So far, we have not opened up the repo, but for now, let's finally open up the repo and look around at what's going on inside of here. The step that we're on now is going to be running this application. And so, oh yeah, environment variables are next. Let's touch our .env.local. And now we have an environment variable file that we can fill in with our environment variables. So here's our Next.js project. And inside of here, we have an env local. Let's copy the environment variables that I've already saved from my other project, and we can paste these right in. And this is all that we need from our environment variables. This is a standard Next.js project. And inside of our app folder, we have our page. This has the bulk of the code that we need. Additionally, we have an API. This API is running the example that we were using before. And so you can see we create an account, we create a smart account, and then these are args to actually deploy a new digital art collectible. You might also call them an NFT It follows the ERC1155 standard from Ethereum. We encode the function data using VM, and then we send that user operation. Again, this is the same sending of user operation we did before. We have a smart account, a network. I'm using a paymaster URL here so that way we can cover the transaction costs. So this wallet does not need to have any ETH in it. And this is a factory for in process, another protocol that I built to allow artists to publish their work on chain with no fees and instant payment. And so it's going to use that factory with the data we passed in. It's using a mock Arweave for the contract metadata. We've given it a name of Coinbase Wallet v2 API, in process edition. The royalty information for payouts, it's going to use no royalty payouts for now, but if you wanted to customize this, a normal royalty payout might be 500 BPS, or 5% of all secondary sales go back to the original artist. Who gets paid out for those funds? Right now I'm using the smart account address, but you can fill in whatever address you want. Who is the default owner of that digital collectible that we're creating? I'm making it the smart account. And this is an empty array of setup actions, but you can fill this in with other setup actions if you want to customize the collection that is being created. We then send that user op, we wait for the operation to complete, and then we reply back with the transaction hash in the smart wallet that's created. We're all just looking at code here, so let's see if it actually works. I believe that's our next step. Let's go into the docs just to verify. We've touched our environment variable file. We filled in all of our environment variables that we need. We're going to add the environment variables to our gitignore just to make sure that we don't push those. And now we can run our server with npm run dev. Let's paste this in. Once our server is running, we can then test it by opening up localhost 3000. And now instead of interacting with the app via a command line, which we've been doing up till now, we're now going to see an actual web page, which is going to be way more accessible to anybody that wants to be using the apps that we're building. And so if you're a builder and before this, you've only ever seen an example of using the Coinbase Wallet v2 in terminal, you can follow these instructions. And what we get here is an app where we can see information about our smart wallet. We can create a new smart wallet. It's going to hit our API. And then when it finishes, we're going to get back the smart wallet that was created as well as the transaction hash. It takes a little while on the first run because the first run, uh-oh, we got an error. That's never good. Unexpected error occurred. Let's see what happened. Failed to create the wallet. Let's see if anything happened in here. So far, we've just seen an unexpected error occurred. I'm not sure what happened, so I'm going to try it again. Let's see if it works the second time. And this time it worked. We have just created a smart account. We got a transaction hash. And let's see if I can just do it again. I'm not even going to wait for the response. Let's try creating a new wallet. And boom, we got a brand new smart wallet. It's already signed its first transactions on chain. And all that we're doing is clicking a button. I'll do it a third time. Let's create a new smart wallet. We're creating an account, creating a smart wallet where the owner is that first account, then using the smart wallet to create digital art on chain. And then we get back that transaction hash. Let's look at that transaction hash. My favorite pair programmer just showed up. Say hi to Solana. Hi, Solana. And so here is that transaction that was just fired. Here it is. We created two accounts now. This first one is our smart wallet, which we can confirm by going back to our app. Smart wallet is 50A. This first address is 50A. The second one is an NFT or digital art. It is a digital art collectible that we have just created. We can click into it. We can check out the contract. And it is a proxy, so we can mark proxy. Verify the proxy. And now we have a verified digital collectible. Go back to the digital collectible. We can read as proxy. And from here, we can check out the name function to see the name that we wrote. This is a Coinbase Wallet v2 API in process. And we should be able to verify this by going over to testnet.zora.co/collect/bsep colon our wallet address or the digital collectible. And let's verify we just created a digital collectible that we can check out on, well, it looks like they may not be letting us share it here. So for now, we can't demonstrate it in this method. Is there another way I can use to test it or to verify it? We should also be able to see it on Third Web. Let's try going to Third Web for base Pulea testnet and paste in our contract address. And we should at least see the name of that digital art collectible right here. Coinbase Wallet v2 API, and it includes anything we need out of a normal digital collectible. We need the ability to buy it, which is our mint method. We need abilities to transfer ownership, to modify the metadata on it. We can update our token URI. Anything you expect out of a digital collectible, you can now do just by clicking a button. Let's go back to that app and let's do it again. Create a new smart wallet, and we're creating a new smart wallet. We're creating a new account, creating a new smart wallet, and then creating digital art using that smart account. Brand new smart account address gives us a brand new transaction hash, which gives us a brand new digital art contract. This is how easy it is now to be building applications that allow people to create digital art. We don't need to have those annoying pop-ups to have people to sign. People don't need to have ETH in their wallets. We can just create the contracts behind the scenes and create the same type of experience that artists are already used to seeing when they go onto Spotify or when they go onto Bandcamp or when they go onto SoundCloud. We can just create that art on chain instead of storing it in a database and create better apps than what already exists with Spotify and SoundCloud and Bandcamp. Right now, all that information is off chain. And so we don't get the benefits like totally transparent infrastructure, knowing that our media is hosted forever and can never be taken down, as well as instant payments. Right now, if you earn on Spotify, SoundCloud, Bandcamp, it takes not instantly. It's at least going to be days, if not weeks, if not months for your funds to hit your wallet. If you're building on in process and someone buys your work, those funds instantly go into your wallet, instantly, without any middlemen. Spotify, SoundCloud, Bandcamp, there are middlemen. There are fees. You have to KYC. It's not available to everybody anywhere in the globe. But if you're building on Coinbase Wallet v2, you can be publishing art on chain and creating platforms for anybody anywhere in the world to publish their art on chain without any sort of KYC. You don't even need to log into this app, and creates a brand new wallet, uses a paymaster so that we cover those gas costs for you. You don't even need to worry about having gas. And then we allow you to create digital art on chain, on Base, instantly. You might say, okay, cool. We've got a localhost 3000 app. I know how to get a localhost 3000 app, but that's no better than what we just had with the Coinbase Quick Start. I agree with you. Let's take this a step further. And now that we've run it locally, let's deploy. In order to deploy, we need the Vercel CLI. And so let's stop running this locally. Let's install the Vercel CLI. The Vercel CLI will allow us to deploy this app onto Vercel, host it for free, and get a link that we can share with anybody who wants to use our app. Anybody can use our app with this new link that we're going to be sharing. While that's installing, again, make sure you're staying hydrated, whether it's tea, coffee it'll dehydrate you, so I don't recommend coffee too much, but if you have tea or if you have water or anything that's going to help you stay hydrated during this masterclass, stay hydrated so that the knowledge that you're learning can stick in. And if you're here following along, make sure that you're taking water breaks so that you can keep up your momentum and keep moving forward. Once we've set up the Vercel SDK locally, we're going to use Vercel login. I'm already logged in, so I'll do my GitHub login, and it's going to say you've already logged in. I'm already seeing success. I've already been logged in with my email. I can return back to the CLI, but for you, log in with whatever account you've got. After we've logged in, now we just use Vercel. Let's just use Vercel command. This is going to set up a new project. I'm going to leave it as the default yes. I'm going to keep it inside of my projects, Sweetman Text projects. I don't want to link this to an existing project, so we'll keep it as no. What's the name? We'll keep this name the same. The directory is located right where I am in // and I don't want to modify any of these settings, so just hit enter. It's just uploaded all of my, it's just uploaded everything into Vercel. And so what I can do now is I can command click on this inspect link, and it's going to take me up to the latest deployment. And now we can watch as it deploys for free, is hosted for free, and gives us a secure HTTPS link that we can share with our friends for free. While it's deploying, I'll click on my project name to go back to my project, go into the settings tab, and what I want to do is add in the environment variables which are missing. Once I'm in the environment variables tab, I'll go into my env local where I've already saved all of my environment variables. Copy those environment variables and just paste them, and it'll paste them all well formatted, and then click save. Once we've done that, we've now added our environment variables into our Vercel project, which is going to allow the app that we're deploying to have access to those. Now, keep in mind, this first deployment has been deployed without those environment variables. And so the first time we try to use this app, it's not going to work. And so what I'm going to need to do is, as soon as this finishes deploying, I'm going to need to deploy it again so that it, now that it's ready, should register that it's ready here as well. And now that it's ready, I'll run that same command to Vercel to create one more deployment. And this should be the last deployment that we need. This is our app. Again, we got this URL for free. And here's the app that we just built, deployed on Vercel. It works great on mobile right out of the box. And so we can view this on a mobile screen, and you can see the styling automatically works for mobile. And now let's try creating. I'm expecting this to fail because, again, we're missing those environment variables. And so all that we have to do is wait. It only takes a minute for this to deploy. It's a very lightweight app. And so in less than 1 minute, this will be deployed with our new environment variables. And now that we have our environment variables, the app is going to work. This should be the last step in everything that we need to do. So at this point, we're just verifying the results, but we now have an app that was deployed to create smart wallets for free, as many smart wallets as you want, using Coinbase SDK's Wallet API v2. The deployment only took a minute. Last time we tried to run this, we got errors saying that our environment variables were missing. We have added our environment variables. We redeployed the app. And now when we create, it's still telling me that we're missing environment variables. I'm going to try doing a full restart. Command-Shift-R. Let's try this again. It's still telling me that we're missing API key ID, API key secret, and wallet secret. Let me verify I have those by coming back to settings, go to environment variables, key ID, key secret, wallet secret, paymaster URL, key ID, I have key ID, key secret, I have key secret, wallet secret, I have wallet secret. I'm not sure why this isn't working. And so what I'm going to do is go back to my deployments tab. What do I want to do here to get it to work? Let's try doing Vercel prod, see if that does anything different. That was the issue. So this preview has not been promoted to deployment. So all that I should need to do is promote to production our latest deployment. And now that URL is going to show our latest, but it's not going to do so until after this deployment finishes. So I'm actually going to cancel the deployment I just triggered. And now it's going to just promote to production. So the issue is that when I did my second deployment, I didn't add double dash prod. And so even though it did the build, I just wanted to promote it. I'm surprised it's doing a full redeploy. Collecting page data, generating static pages, collecting build traces. Should be about to deploy, and once it starts to deploy, it's only another 10 seconds. It's a very fast build. It's deploying, so we should be ready any second now. We're now ready, same domain, refresh it. Let's try it again. This time it should work because I actually updated our production environment. Click on the button. It's creating a wallet. Drum roll. Boom. Smart account address, transaction hash. Everything looks great on mobile, but we're on desktop, so I'll expand it a little bit. We have our smart account. We have our transaction hash. Let's do it again just to show, again, We can create as many accounts as we want. This is one of the big benefits we get with Coinbase's Wallet v2 API. We got a brand new smart account, brand new wallet. Let's do it again. Create another one. We're creating 3 accounts in about 30 seconds. And this has been an hour. So I think it's about time for me to start wrapping up. Let's verify how this looks on Basepolia Scan. If we check out this transaction hash on Basepolia Scan, it happened 9 seconds ago. We created our smart wallet that starts with 12A and ends with DDD6. Our smart wallet over here, you can see starts with 12A and ends with DDD6. We also created this contract, which is a digital collectible, and we can see that in our logs over here. Here's our smart wallet being deployed, our before execution, our upgraded, set up new contract. This is coming from in process. This is coming from our creation of a new digital art collectible. We've got the creator, which is our smart wallet, as well as the default admin, also our smart wallet. We updated the permissions. We updated the token. We should have updated the royalties as well. And then we transferred the ownership to my smart wallet so that it's the new owner. All of this happened in one single transaction behind the scenes. We are creating smart wallets and creating digital art with those smart wallets, which allows us to keep our actual artist wallets safe, secure, not signing random transactions, but while still owning all of the art that is being created from it. To briefly recap, in this video, we followed the Coinbase Wallet v2 Quick Start. We've highlighted the differences between the V1 Wallet API and the V2 Wallet API, which main differences are private keys used to be I had to manage a file and I was responsible for maintaining private keys. Now the private keys are all stored in a TEE, a trusted execution environment that Coinbase doesn't have access to, I don't have access to, which is much safer private keys. We went from only being able to have one single network and one single secret per account. And so I had to have an account that was on Basepolia, a different account that was on Base Mainnet, and none of those had the same address. To now we have one single secret, and it allows us to create infinite accounts on multiple different chains. Before we only had one chain. We also get VM compatible, which I showed how we use VM. We also got gas sponsorship. I showed you how to use Paymaster. And again, if we didn't highlight the Paymaster very well, Paymaster is inside of our route, inside of wherever we're sending the user operation. We just pass in a Paymaster URL, and this Paymaster URL covers the gas so that we can spin up brand new accounts, don't have to send any ETH to it, but it can still execute transactions like creating digital art on chain. Once we talked about those differences, we actually showed you how to set up the local project. This is following the official Coinbase docs on how to use the Wallet v2 API. We showed you how to create an EVM using cdp.evm.createAccount. We showed you how to fund an account using cdp.evm.requestfaucet. We showed you how to set up a smart account using cdp.evm.createsmartaccount. How to send general transactions using cdp.evm.sendUserOperation. And then I even showed you how to add all of these new tools inside of a Next.js project that you can deploy in one click. That is this final app that we built that anybody can access. I have this link. I can share it with all of my friends on April 28th wallet v2 app.vercel.app. And anybody can come here, click a button, create a new smart wallet, and then look at that transaction to see what that is doing on chain. What this is going to next is the next thing I'm going to be doing after this video. I'm obviously going to update the docs to add in the correct v0 code. That's going to be a quick fix. But in my own personal practice, I'm going to be using the Wallet v2 API to add into Recoup as well as into Coop records. I'll talk specifically about Recoup because that has the most direct application to what I'm building this week. I am going to be using the Coinbase Wallet v2 API to make it so that whenever we generate an image using Recoup, and so if you go into the Recoup assistant and say, generate a new image of my cat in the style of Studio Ghibli, when you send that, it'll use OpenAI's image generation to generate that image. And then we'll use Coinbase's Wallet SDK to create a new wallet. And then we will publish that image that was just created on chain, on Base, using the Wallet v2 SDK and giving ownership of that image to the wallet that is signed in using Privy. What that allows is a new style of image generation using AI that you don't get when you use Midjourney and you don't get when you use OpenAI or any of the other image models. When you use any of those models, you can say, I made this image and I made it first. But if OpenAI uses that image in their marketing, you don't really have any sort of provenance over that. And so what we're doing at Recoup is making it so that whenever you generate an image, we're storing that image on chain on Base and linking it back to you. So that way, one, if you ever want to see what is every piece of art that image I've ever generated using Recoup, you just go to your wallet on chain, and then you'll see every single time the exact timestamp and the exact piece of art that you created. Additionally, if you ever want to monetize, the art is already listed on chain, and it makes it very easy for you to then go over to in-process and list the sale price onto that and then earn money off of the art that you're making. But I think the most important thing, without worrying about the monetization layer, is that provenance. So that as you're using Recoup and you're chatting with an AI assistant and you're generating image assets, if it ever comes into question of who generated this image, you can always go back to the transaction on chain and say, here's an on-chain transaction that makes me the owner, the undeniable owner, the first person to ever have generated this image. And that is the linkage between the AI app that I'm building over with Recoup and AI assistant for musicians to be able to have a record label in their pocket, with the work that we're doing on chain with Base and Coinbase to make it so that any AI agent has a wallet. It intersects with artists' ability to have provenance with the art that they're making. This is just one intersection of many. And it's one of the reasons I'm super excited about these updates. The fact that I can now create 1 million smart accounts and use Paymaster to fund those means that I can just use a wallet for one-time art creation, store that art, and give the admin access to the external account that's signed in. But the external account didn't have a friction point of having to sign a transaction. They're doing the same experience that they already see with OpenAI and Midjourney, where they don't have pop-ups asking them for transactions. They just say, I want an image is generated. But the difference of what you get with OpenAI and Midjourney is we invisibly stored that image on chain. We stored it on Arweave, so that way the image is there forever and permanently. And then we created a digital collectible using Base and in process so that you didn't need to know, but that image is stored on chain and linked back to your wallet so that you always have provenance and can always tell everybody else, this is the art that I made. These are the images I made. This is how I used my AI agent. Oh, you don't agree with me? You don't believe that I'm right? Here's the transactions. And just give them the receipts so that they know this is exactly how you did it, and it's all transparent and accessible. If you made it this far, leave a comment down below if you're building this out. If you have any questions on how to take your app to the next level using Coinbase Wallet V2, leave us a like, give me a subscribe so that this content can reach more people, so that more people can see exactly how to use the Coinbase Wallet SDK to build the next generation of on-chain apps. And again, if you're not subscribed, give us a subscribe. I'm constantly building out in public, and it really helps. All the buttons that you click get more people tuned in, which allows more people to be building on Base and accelerates our progress to helping apps reach 1 million users and to bring 1 billion people on chain. Thank you for tuning in. I'll catch you real soon with my next live stream.